Hello, my name is Connor Mason, and I'm going to be discussing the 4 stages of skeletal muscle contraction. So, the first stage I'm going to be talking about is excitation of a muscle fiber by a somatic motor neuron. So, this will happen at the neuromuscular junction, which will include the synaptic knob, synaptic cleft, and the motor end plate. So, calcium will go into go through voltage-gated channels, and this will allow it to diffuse down against the concentration gradient. And calcium will also bind to protein. So this binding of proteins will trigger vesicles and enter a group of people, like the group itself. And people are acetylcholine. So then the vesicles will merge with the cell membrane at the synaptic knob and will release acetylcholine from there. And this is all occurring because of a nerve impulse called an action potential. So then the next event I want to bring up is excitation contraction coupling, and this event will include the sarcolemma, the transverse tubules, and the sarcoplasmic reticulum. And something called the end plate potential will trigger an action potential to spread out along the sarcolemma and the transverse tubules, and sodium will rapidly diffuse into the cell, causing it to depolarize, and this will cause adjacent sodium channels to also open, and then this process will continue going until it reaches an end, which is why I drew matches catching each other on fire instead of dominoes. So then once sodium channels close, then potassium channels will open, and then potassium will go out of the cell, which will cause it to repolarize. And then when the action potential travels down the T tubules, it causes calcium release channels in the T tubule membrane to prompt calcium release channels in the sarcoplasmic reticulum to open. And when calcium is released from these, it will bind to troponin, and this will cause troponin to change. So the troponin and tropomyosin complex that is bound to calcium is moved and will reveal a myosin binding site. So then this brings me to the third stage, which is calcium cycling and cross-bridge calcium binding, and cross-bridge cycling, which occurs at the sarcomere. And I tend to view calcium cycling as what triggers cross-bridge cycling. Calcium binding. So when troponin and myosin move, an actin binding site, which is a specific region on actin myofilaments, will be exposed, and there are 4 steps of cross-bridge cycling. The first step being cross-bridge formation, which is where a myosin head will connect to an exposed binding site on the actin. And the next step would be the power stroke, which is where the myosin head will swivel and then pull thin filaments towards the center of the sarcomere. And then the third step would be the myosin head being released by a adenotriphosphate binding to it and releasing it from the actin. And the final step is resetting the myosin head, which is done by adenotriphosphate splitting into adenodiphosphate and phosphate. And then by myosin, this is caused by myosin adenotriphosphatase, and this gives energy to cock the myosin head. now for the final stage, which is muscle relaxation. Uh, some occurrences in muscle relaxation is the termination of nerve signals, and acetylcholine release. Uh, and there's the termination or the hydrolysis, which is the breakdown by water molecules. The hydrolysis of acetylcholine by acetylcholinesterase, and then the termination of acetylcholine receptors will cause end plate potential to halt, and calcium channels in the sarcoplasmic reticulum close, and no more action potential is generated. It's like everything is locked up and just stopped. And then troponin will regain its original shape. And the troponin blockade will return as well, and the muscle itself will return to the original position it was due to the elasticity it has.